Hey everyone, Mr. Newman here, and today we're going to learn about arithmetic sequences. First of all, what is an arithmetic sequence? Well, a sequence is just a list of numbers, so this is a list of numbers that increase or decrease by the same amount each step. For example, 3, 5, 7, 9, that's an arithmetic sequence because it increases by 2 each time. 100, 92, 84, 76, that's an arithmetic sequence because it decreases by 8 each time. Here's an example of one that is not an arithmetic sequence. Even though you see a pattern, it's not increasing by the same amount each time. And here's another example of a pattern, 1, -1, 2, -2. Yes, you can see a pattern, and every other one is maybe an arithmetic sequence, but it is not an arithmetic sequence because it doesn't increase or decrease by the same amount each time. So how do we find the formula for an arithmetic sequence? Well, there are two types of formulas. There's a recursive formula and an explicit formula. Instead of giving you definitions, let's just look at an example. So, right here, this is my step. N is a letter that represents which step you're on. So, for example, 100, that's the first step of this sequence. 88, that's the second step. 76 is the third step, and 64 is the fourth step. So I'm going to put this into a table. That's always the first good idea, is to write this down in a table so we can picture it. And I'm going to skip the first space, and I'm going to write 1, 2, 3, 4 over there to the right. We'll see at the end why I skipped the first space, but skip that just like me. Then go ahead and fill out what f of n is. That's just a way of saying which step. So f of 1 is 100, f of 2 is 88, f of 3, in other words, the third step is 76, and 64. Now that it's in a table, we can find our rate of change, or look at how much the x is, or the n is changing by and the f of n is changing by. F of n will always go up by 1 each time for arithmetic sequences because each step goes up by 1. Just like in the visual patterns that we do, step 1, step 2, step 3, step 4, that's always going to go up by 1. Here, f of n goes up, or rather down, by 12. And that happens every time. So this is definitely an arithmetic sequence. And we want to look at what is a recursive formula. Well, do a recursive formula. Oh, first, actually, I'm going to fill in the last box here. We're going to use that as a check later. So I added 1 to the top and subtracted 12 on the bottom. To do a recursive formula, you need two things. You need the first step, and you need every other step defined. So we're going to write down the first step right here. F of 1 means the first step. Well, the first step is 100, and I got that from that column right there. So f of 1, the input is 1, the output is 100. Then we need to do figure out f of n. And the way you do this is you write down it equals f of n minus 1, and then it's plus or minus whatever we're going up by. So here, this is minus 12 every time, so we're going to put minus 12. Now let's talk about what do these letters mean. Well, first of all, f of n, that is the current step. Okay, that's like this step right here. F of n minus 1 is the previous step. And if you think about what input means, that kind of makes sense. If you're on step n minus 1, in other words, 1 before the step we're on, that's the previous step. So f of n minus 1 means the previous step. So what you do is you take the previous step and you subtract 12 from it, and you get the current step. So here I'm going to circle a few things. Let's say you're on step 3. You're going to take the previous step, you take 88, you're going to subtract 12, and you get the current step, which is 76. So that's how we calculated this last one. So step 5, we took the previous step, that was 64, and we're going to subtract 12 from it, we got 52. Now, this recursive formula is all nice and good, but there's a problem. We can't figure out step 100 quickly. So that is where explicit comes in. We could figure out step 100 if we add over and over and over and over, but that would take a long time. So we always need to figure out the explicit formula as well. And I'm going to give you a formula up here. So write this down right next to your table. F of n equals f of 1 plus d times n minus 1. This formula will always work and always help you figure out the arithmetic sequence explicit formula. Now, I am going to show you a way to do it without the formula, but for those of you who prefer memorizing the formula and using that formula, you can memorize this and use it. The other way requires a little bit more thinking and understanding, but that's just fine depending on which way you like to do it. So the parts of these formula. First of all, f of n means the current step. So if we're on step 5, it means what the output of 5, f of 5, okay? F of 1 means the first step. Those are both shown over here. We had f of n and f of 1, okay? And D right here is the difference. And the previous time I said that was the change in value. So you can think of it either way, but they use the letter D because it stands for difference. So to get from 100 to 88, the difference there is you subtract 12. So D would be negative 12. And this last part, n minus 1, is just in parentheses. And we'll talk about why that is, okay? So first thing we're going to do is we're going to write down our formula. F of n equals f of 1 plus D times n minus 1. Then I'm going to replace each part other than the first part. F of n is still our current step. This is what we're writing the formula for. So now we know it's a function. F of 1 is the first step. That is 100. So I'm going to plug in 100. Plus D. D is the difference. That's negative 12. So you could put plus negative 12, or you could just change it to minus 12. They mean the same thing. And in parentheses, we're going to put in n minus 1. This right here is the formula for the nth step. So if I want to figure out step 100 very quickly, I could plug in 100 there. It would be f of 100 equals 100 plus negative 12 times 99, because n minus 1, 100 minus 1 is 99. Well, that's one way to figure out the formula, just using this formula here. The other way to figure out the explicit rule or the explicit formula is to find the zeroth term, the zero step. So you guys see right up here, I left that blank because I want to fill in the zero step here. And you just kind of have to work backwards. Well, I know that we subtract 12 to get to the next step. So what would I start with if I had to subtract 12 from it and get 100? Well, that number would be whatever 100 plus 12 is, right? It'd be 112, because 112 minus 12 is 100. Now here's the nice thing about this. Once I've found that zero step, that is my starting value. Even though the arithmetic sequence really starts at 1, when we're talking about graphs, and a lot of times in math, we talk about the zero step because we plug in 0 to start the value, or to start the formula. So now that I have that step, the formula is just this. Negative 12n, because negative 12 is what we change by each time, plus 112, plus that starting value. And the reason I like this is because this connects to things we've done before. We've done mx plus b before. You guys have done that before, where m is the slope or the rate of change, and b is the y-intercept or the starting value. You see, y-intercept or starting value, that's when x equals 0. So here, when n equals 0, that's going to give us our starting value of 112. M, the slope or the rate of change, is just the rate of change. We've calculated that before. And so all these things we've done before, other than now we're just calling it n because there are integer values instead of any value. But n, x, they mean the same thing in this situation. So this connects back to something you've done before, and I think you have to memorize less, but you do have to figure out a little bit more. You can choose whichever way you want, and that will work great. Now, we need to check our work. So what I'm going to do is I'm going to check our work with this funny formula we found up here, and I'm going to use it. I'm going to use plugging in 5 here. I'm going to plug that in, and we should get out, if we plug in 5, we should get out 52 to check our formula. So let's plug in 5 here. We're going to write down the formula, but instead of n, I'm plugging 5 in here, so I'm going to put a 5 right there. And you could type this in a calculator, but make sure you follow order of operations if you don't. 5 minus 1 is 4, so I'm going to write that down. Then we do 4 times 12, because multiplication comes before subtraction. And 100 minus that is 52. So we checked it, and it is what we thought it would be. Check. It's always a good idea to check your formula, just like we do with our visual patterns warm-up, just to make sure you got the right answer. And you could check it with any of these numbers. I just checked it with the largest one that we happen to have. All right. Now, I'm going to get you started on this. So 0 is the first step. 8 is the second, 16 is the third, 24 is the fourth, and 32 is the fifth step. I want you to fill out the table and write down a recursive and explicit formula, and you're going to try all of this on your own. Please refer to your notes on the other side of the paper, and thank you for watching.